This video, we're going to be given a single complex zero, and we're going to use that to find additional zeros of our polynomial. So we're going to use the fact that a squared plus b squared breaks down into a plus bi times a minus bi, and what we discussed in the last video, that every time that I have one of these factors, I have to have the other one because they come in conjugate pairs. So that's always going to force a factor of a squared plus b squared. Then I'm going to be able to use long division of polynomials and come up with hopefully a quadratic equation or something maybe even linear that gives me another root that I can solve. Let's look at this first one. If I have a given zero of x equals negative 2i, that forces me to have a zero as well of x equals positive 2i. That gives me factors of x plus 2i times x minus 2i will give me x squared plus 4. I'm going to put x squared plus 4 on the outside of my long division. I'm going to put x to the fourth minus 32x squared minus 144 on the inside. I'm leaving some space if I need it for the 0x cubed. I'm leaving some space for the 0x here if I need it. So x squared goes into x to the fourth, x squared times. It gives me x to the fourth, and a positive 4x squared. I'm going to change my signs and add. Don't need my x cubed term. This is going to be a negative 36x squared minus a 144. This is going to be a negative 36. This is a negative 36x squared. 4 times 36 is 144. Change my signs and add. There's a remainder of 0, which makes this x squared plus 4 times x squared minus 36. That leaves me with x plus 6, x minus 6. If I want to break this down into linear factors across the complex numbers, this is going to be x plus 2i, x minus 2i, x plus 6, and x minus 6. 1, 2, 3, 4 factors for a fourth degree polynomial. So all of the zeros here are x1 was given to me as a negative 2i, x2 is its complex conjugate, positive 2i, then I have a negative 6, and I have a positive 6. 4 zeros for my fourth degree polynomial. Let's try this one now. X to the third plus 6x squared minus 14x plus 16. And my given zero is x equals 1 plus I. That means that I have a second complex zero of 1 minus I. So that gives me x minus 1 minus I times x minus 1 plus I. Let's go ahead and let's expand all of this. This is x squared minus x plus xi. This is a negative x plus 1 minus I. This is a negative xi. Then this is a plus I. And this is a minus I squared. Is going to be the same as a plus 1. These parts with i's. should zero out, and I should end up with x squared minus 2x plus 2. That goes on the outside. X squared goes into x cubed x times. X to the third, negative 2x squared, positive 2x, change my signs and add. 8x squared minus 16x, drop down the 16. X squared goes into 8x squared 8 times. 8x squared minus 16x, positive 16, change my signs and add. So that gives me that my factors here are x minus 1 minus I, x minus 1 plus I, x plus 8. And my zeros are 1 plus I, 1 minus I, and if I set x plus 8 equal to 0, I'm going to get a negative 8. Let's try x cubed minus 3x squared minus 5x plus 39. They were nice and gave us a real 0 this time that we can just use with synthetic division. So that gives me x plus 3 times x squared minus 6x plus 13. I'm not going to find any factors of 13 that add to give me negative 6. There's going to be complex answers here. I'm going to complete the square to find those answers. Half of a negative 6 is a negative 3. Negative 3 squared is a positive 9, so I'm going to add 9 to both sides. That makes my left-hand side x minus 3 quantity squared. That equals a negative 4. I'm going to take the square root of both sides. X minus 3 is equal to plus or minus 2i, and x is equal to 3 plus or minus 2i. So my answers here, my x1 was my given negative 3, my x2 is 3 plus 2i, and my x3 is 3 minus 2i. All right, now we have x to the third plus 8, x squared plus 25x plus 26. We're given the 0 of x equals negative 3 plus 2i, which guarantees us x2 of negative 3 minus 2i. That gives us factors of x plus 3 minus 2i and x plus 3 plus 2i. I'm going to show you something kind of tricky here. Change these to brackets. I'm going to put parentheses here. Change these to brackets. Brackets are just parentheses outside of parentheses. So you see the innermost set of parentheses there. And I'm going to treat this like it's a minus b, a plus b, which is going to turn into a squared minus b squared, where a is equal to x plus 3 and b is equal to 2i. If I square x plus 3, and I square 2i, This is going to be x squared plus 6x plus 9 minus, that's going to be a -4. And we knew that from the previous problem, right? Because that's what the previous problem broke down into. And we have x cubed plus 8x squared plus 25x plus 26. X cubed, 6x squared, 13x. Change our signs and add. And this is going to be plus 2. Change our signs and add. So it gives us x plus 3 minus 2i, x plus 3 plus 2i. Our x1 was -3 plus 2i. Our x2 was a -3 minus 2i. And our x3 is going to be a -2. Two x to the fourth minus 15x to the third plus 45x to the second minus 45x plus 13. There's a given 0 of x equals 3 plus 2i, which means that there's another one of 3 minus 2i. Let's go ahead and do something. Let's do the same thing we've done before. X minus 3 minus 2i. X minus 3 plus 2i. This is going to give us an x minus 3 squared minus 4i squared. X squared minus 6x plus 9 plus 4. X squared minus 6x plus 13. Let's keep using that long division technique. To x to the fourth minus 15x to the third plus 45x squared minus 45x plus 13. It's going to be a 2x squared. 2x to the fourth minus 12x to the third, 26x squared. Change my signs and add. A -3x to the third, a -19x squared, and bring down that -45x. This is going to be a -3x, -3x to the third, positive 18x squared, minus 39x. Change my signs and add. -11x squared. No, sorry, -1x squared. That was an 18. There we go. Minus 6x. Then I'm going to bring down the plus 13. Uh-oh. This is positive. This is negative, and that's positive. There we go. And this is plus 1. This is x squared minus 6x plus 13. Change my signs and add. Get a remainder of 0. So this is x minus 3 minus 2i, x minus 3 plus 2i, and this is 2x squared minus 3x plus 1. So this is x minus 3 minus 2i, x minus 3 plus 2i. This is 2x and x. Both signs need to be negative. 1 and 1. So that's a -2 and a -1 give me a -3. X1 is 3 plus 2i. X2 is 3 minus 2i. X3 is 1/2. X4 is +1. Last problem in this video, x to the 5th minus 10x to the 4th plus 42x to the 3rd minus 124x squared plus 297x minus 306. We have a 0 of x equals 3i, which means that we have an x equals -3i as well, which gives us an x squared plus 9, x to the 5th minus 10x to the 4th plus 42x to the 3rd minus 124x squared plus 297x minus 306. Be an x to the 3rd, x to the 3rd, 9x, sorry, x to the 5th, 9x to the 3rd, change my signs and add. -10x to the 4th plus 33x to the 3rd minus 124x squared. Right. Then this is going to be minus 10x squared, -10x to the 4th minus 90x squared. Change my signs and add. 33x to the 3rd minus 34x squared plus 297x be plus 33x, 33x to the 3rd, 27, 27 and 2 is 29x. Change my signs and add. -34x squared minus 306. This is going to be a -34, -34x squared. I'm going to take it that is a -306. It is. Add, get a remainder of 0. This is an x plus 3i, x minus 3i, x to the 3rd minus 10x squared plus 33x minus 34. We cannot factor by grouping on that one, so we need to use some of our other techniques from before with the rational root theorem. Factors of 34 are 1, 2, 17 and 34. Factors of 1 are 1. So I'm going to try 2 on this. 1, negative 10, 33, negative 34. 2, negative 8, negative 16, should give me 17. 17 times 2 is 34. Gives me 0. This is x plus 3i, x minus 3i, x minus 2, x squared minus 8x plus 17. There are no factors of 17 that add up to give me negative 8, which means that I would need to complete the square. 8x equals a negative 17. So half of negative 8 is negative 4. Negative 4 squared is 16. Add 16 to both sides. X minus 4 squared equals a negative 1. X minus 4 equals plus or minus I. X equals 4 plus or minus I. That gives me an x1 of 3i, and x2 of a negative 3i, and x3 of a positive 2, and x4 of a 4 plus I, and an x5 of a 4 minus I. We should have 5 zeros because it was a degree 5 polynomial. That's going to be it for this video. Go ahead and come back and find all the zeros of a function not being given any to start off with in our next video.